This is chapter 12 of the Network Plus class, and today's topic is IPv6. Remember we talked about IPv4. We said there were two versions of of TCP/IP. IPv4 we discussed at length several weeks ago. IPv6 is now. You're not going to have to know a whole lot about IPv6. It's still not widely used, especially in the United States. It is used extensively in Asia. But IPv4 is what you're going to be using for the next several years here in the United States, unless you're working for a very, very large corporation or maybe an ISP, something like that. IPv6 is 128 bits long in its address. Remember the IPv4 was 32 bits. This is 128 bits. IPsec, remember we talked about that back in security and VPNs a little bit. This is built in to the protocol suite. IPv6 has more efficient routing. And the addresses, rather than decimal addresses, IPv6 addresses are 8 sections of 16 bits each. It's in hexadecimal format. Hexadecimal format. And each section is separated by a colon. Colon. Furthermore, the IPv6 address is broken into two parts. So we have two parts of 64 bits each. Your first section, or there we go. The first 64 bits is the network prefix. And this is used for routing. The second 64 bits is the user address. And this is called the interface ID. Then the network prefix is further broken down into global and subnet IDs. So let's take a look at a sample IPv6 address. ABC2 colon 1234 colon 1234 5 6 7 2 3 4 So we have 8 sections. So up here we have 8 sections. 1, 2. So we're going to go 1, 2, 3, 4, 5, 6, 7, 8, separated by a colon. Give me a second here. I'm gonna, oops, that period doesn't go there. Break this apart. So the way this works here is here, this part here is your interface ID. This first section here is your network prefix. These last 4 here, that is our subnet ID. And this is our global prefix. That's how it's broken down. We have the ability of taking leading zeros, in each 16-bit section are optional. All right. So we said we could eliminate leading zeros in an IPv6 address. So what I've got here is an IPv6 address, and you can see this has got 1, 2, 3, 4, 5, 6, 7, 8 sections, all 16-bit, all separated by colons. We have some zeros here, 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 oops, and there. Of these are leading zeros. This is a trailing zero. These are leading zeros here and here. So how do we rewrite this IP address? BEEA : now we're going to eliminate the leading zeros. 1, 3, 1, 2, 3, 6, A, B, C, and the trailing zero, : 2, BEA, : 43, FCAB. And that is how we eliminate leading zeros. We can use the 2 colons to eliminate 2 or more sections of consecutive zeros. Again, we'll quick demo here on this one. ABCD : 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. So this can be written as ABCD : Now in this case, these 2 colons here are going to substitute for this whole bit right there. Six, 7, 8, : 6, A, B, C, 7123 colon. Now remember up here, we get rid of those leading zeros. We can do the same thing here and have this as simply an 8. Now it's important to know that this double colon here can only be used once in an IP address. You've got to remember we have 8 sections. 1, 2, 3, 4, 5, 6, 7, 8. And when we do this, it's a simple mathematical equation. We know that these two double quotes stand for, if we go 1, 2, 3, 4, 5, stand for 3 consecutive sets of zeros. If we put in another set of double consecutive zeros, we wouldn't know how many sections we have in our IP address. So let's do a quick conversion the other way. So we'll convert ABC0 colon 1 2 3 4 colon 8 colon 6AC colon 4 6 colon 12 to its full IP address or IP display. So to do that, that would be ABC 0. Now we've got to do some colon. So let's count over here how many we have. 1, 2, 3, 4, 5, 6. So that means this colon right there must have been 2 sets of consecutive zeros. That would have been 1 2 3 4 colon 1 2 3 4 colon 1 2 3 4 colon 8 colon 6 AC. Oops, sorry, 0 6 AC colon 0046 colon 12, and we should have 8 sections here. 1 2 3 4 5 6 7 8, and again that could have been 0012. I just left it as 1 2. As in IPv4, we have some special addresses. Colon 1. Actually, I just put the colon 1. This is an IPv6 loopback address. Very similar to the 127.0.0.1 loopback address we had in IPv4. And we also have a few addresses that are not allowed. So all zeros and all ones are not allowed. You're going to hear the term link local address. These are given to a device after booting. By the OS. This is not a DHCP address. This is actually the operating system itself giving this address. Link local addresses. Always start with FE80 colon. Now that is important to remember for the colon. So those are, that's a link local address. Last 64 bits are randomly generated. Now, for those of you taking a Cisco course, especially an older Cisco class, and older operating systems used to include the MAC address as part of the link local address. Those are, that's not the case anymore. So, and Cisco, in their last CCNA exam, was still saying that the link local addresses included MAC addresses. That is not the case anymore. They are truly just random. So in older OSs, the last 64 bits included the MAC address of the device. A link local address will not be routed on the internet. It's used for local access only. So if you want to route an IPv6 address on the internet, a registered, you need a registered IP address. So where do you get a registered IP address? Regional internet registries. Issue So if you want an IP address, you have to go to your ISP, unless you're a very large corporation. If you're a large corporation, you can go to the Internet Registry. When you have a registered IP address, the first 48 bits are issued by the ISP or registry. (16 bits) are used for the subnet, and 64 bits individual devices. So again, let's just pick a random sample of an IP address. So when we're talking about these, the first 48 bits here, that is from the ISP. This section here is subnets. And these are your individual devices. IPv6 does not support broadcasts. So you're going, whoa, how do they, what do you mean they don't support broadcasts? Broadcasts are like everywhere. DHCP is a broadcast. ARP is a broadcast. A lot of these things are broadcast. Well, IPv6 uses multicast. And the multicast has got their own unique format. So give me a second here. So IP multicast has the following format. FF, and then a 0 or 1.